Good morning and good evening, everyone. I welcome you, all of you, to this first session of our circle, DevOps Foundations with AI assisted workflows. So,
Mhm.
first we will cover the basics, and in the second session, we will cover the advanced options. So, at the end, your feedback will be very valuable, so please keep in mind. In the first session, which will be today's session, the plan is to talk about the core tools and practices, which includes DevOps definition, about Docker containerization and the CI/CD pipelines and AWS fundamentals. So let's start with what is DevOps. So DevOps is basically the culture and practice of connecting the software development and operations team to have seamless integration between their operations. In a normal software development and normal software delivery, we have a developer team and the infrastructure or operations team. The developer team builds the system, and the infrastructure or operations team is responsible for managing the infrastructure, getting the code deployed to some um, server, and things like that. So DevOps is all about automation, where we reduce manual work and increase the efficiency. In modern times, the DevOps is about making everything continuous, from integration to delivery to deployment and monitoring. At the end, the goal of DevOps is to ship faster, break less, and recover quickly. The typical DevOps life cycle looks like the following. Since it is very tightly connected to the whole software development lifecycle, it has some part from the software development lifecycle as well. The first step is the planning, where we collect requirements and design. And the second step is code. This is where the actual development happens. In the third step, we build whatever software we have coded, and we do automated testing, and ultimately we release the deployment and we deploy the software to our infrastructure. And lastly, we complete the whole process by having a robust monitoring system so that we can quickly recover from failures and detect what's wrong with the system. Okay, so that was about the basic definition of what DevOps is. Let's get into the first session. You might all have heard about Docker. It's ubiquitous these days. So Docker is a containerization platform. And what is containerization? It's a process of bundling an application and its dependencies into a single lightweight and portable package. That package can be run everywhere in various infrastructures. Basically, it ensures that if it runs in one system, it will run in the other system as well. There are some basic concepts for Docker that we need to know. The first one is the container itself. As I mentioned earlier, the container is a lightweight standalone package of software that can run anywhere with similar outcomes. Next important part is image. Image in Docker, in the context of Docker, is a blueprint or template that defines the whole application that we are building and is used to create the containers. In the process, what happens is we create an image, we define an image in a Docker file, and we build that image and we run that image as a container. So what is Docker file? Docker file is a simple text file that contains instructions for building a Docker image of the application. Another important tool is Docker Compose. Docker Compose is kind of a wrapper around Docker that allows to run multi-container systems. And like every system that we have is almost multi-container system because even the simplest application is also going to have application and a database server. So using Docker Compose makes deploying and running the multi-container or multi-service systems seamless and very easy. And finally, Docker Hub. It's a cloud-based registry for Docker images. Think of it as like GitHub, where different people can push their code and make their code public and publish. Alternatives to Docker Hub are the GitHub repository, container repository as well. It's provided by GitHub, and most of the CI/CD pipelines in GitHub use the GitHub's repository. So how do we work with Docker? The first step in Docker, in using Docker, is to build an image. So we will have defined a Docker file, and we will also have a final session at the end of this a workshop at the end of this session where we can do some kind of hands-on um, with Docker files and CI/CD pipeline. So the first step is to build a Docker image, which is built using the Docker file. And then after the image is built, we just run the container, exposing the ports. We will look into this in the hands-on workshop later on. And generally, we view the running containers with Docker PS, and we can view logs, and we can start and stop the Docker containers. And here's a sample Docker file. It generally starts with a base image, and everything that follows is our application specific things like, okay, copying the configuration, installing the dependencies, and finally it ends with the command that runs our application. Okay, so let's move on to the next part of this session, which is CI/CD pipeline. So what is continuous integration? Continuous integration is having regular merging of our code into a central repository, running automated testing on top of that, and after the test pass, we do automated builds. So the flow is like that. We or the developers make changes to software code, and then they push it to the repository, and then CI starts, and then all the automated steps start where we run test, we do linting, and after everything passes, after we have made sure okay our code is of highest quality and everything passes, we build the images or we build the package. So the purpose of continuous integration is to have faster feedback. So whenever we push a code and then automated tests are run, then we can catch bugs earlier. And also on top of that, we can also ensure code quality in the CI pipeline. For example, if our code is correctly formatted or not, or if there are any security vulnerabilities in any of our dependencies in the system. And one great example for CI is GitHub Actions, which I think you might have already heard about. This brings us to the next part, which is continuous deployment. It typically follows the continuous integration part, where the continuous integration part gives us the well-tested system or software packages which we will deploy into our infrastructure. The purpose of continuous deployment is to get faster feedback from users. It enhances the user experience because users get to see new features and fixes fast as soon as our code is pushed. So it also is efficient in terms of time and cost because there is from little to no manual process involved. Let's have a quick look at GitHub Actions as well. So it's a native GitHub integration of CI/CD pipeline. GitHub Actions are generally defined as YAML configuration file, and GitHub Actions do trigger on certain events that happen in the repository, like certain push in branches when a PR is opened, when in in our defined schedule or even other manual processes. We can also trigger GitHub Actions when there is a issue or ticket opened by users. One good thing about GitHub Actions is it has a huge marketplace of reusable actions. We can see these in action in the workshop as well. So basically, GitHub Actions are generally defined inside .github/workflows directory, and it's a common practice to check it into the repository. Okay, we will also look into the GitHub action in detail, but here's a sample action. We have name. We define what triggers this action, and each action has jobs. Basically, jobs can be multiple in a single action, which can run in sequence or in parallel. Here, there is only one job, and each job has certain steps that it must follow. And it's in the steps where we run tests, we install dependencies, we build Docker, and we push the Docker images. And secrets management is oftentimes overlooked, but it's a very crucial thing because it is, I mean, it is not a very technical thing, but it's more of a management thing. So it's very easy to ignore the secret management. The first principle of secret management is never hardcode your secret, neither in code nor in config. As we will see later, it's even harmful to have secrets in the commands that we type in the remote server. So for this reason, different hosts or different platforms have their own secret management services. For example, GitHub has GitHub Secrets. And in the GitHub Actions, we can access the secret using this format, secrets.name. And similarly, AWS also provides secret management service where we have centralized secrets for all the applications that we use under AWS. While talking about secrets, one common thing that we need to also talk about is environment variables, which are generally loaded at runtime and not on build time. And it's also possible that while setting environment variables, we might be leaking our secrets, as we can see in the example below. In this case, what we are doing is we are trying to run npm run deploy by setting an environment variable. The environment variable actually is a secret key. It's technically possible to do it this way, but it's not a safe thing to do because anyone having access to the server can just look at the history of the commands and see the secret. The good alternative practice to this is doing like this. We first export the secret key, not directly using the key, but using secret manager. Once we have exported the secret key without exposing the key itself, we can then run the command. Okay, let's get into AWS fundamentals now. So we all know AWS is Amazon Web Service. It's a cloud platform that provides various services for deploying our software. Here are the key services that AWS provides. The first one is, and the mostly used one is EC2. It stands for Elastic Compute Cloud, and it is basically virtual servers in AWS Cloud. The next is S3, which stands for Simple Storage Service. It's basically a key value storage. The value is generally file, and we generally store our database backups or static site files like JS, CSS, and HTML files. Another crucial part service is RDS. It stands for Relational Database Service. It's a managed database service provided by AWS, and it has support for multiple databases, but on top of those are MySQL and PostgreSQL. RDS also provides automated database backups, database clusters, data transfers, and things like that. Generally, EIPs are associated with EC2 instances. And how it works in AWS is that EC2 instances, if when they are started, they get their own public IP, and whenever they restart, the public IP might and most likely will change, and that's not desirable if we need to have an application deploy, right? So that's the case when we assign some elastic IP to a particular EC2 instance, and no matter how many times the EC2 instance goes down or up, the IP remains the same. Another service is CloudWatch. It's basically for logging and monitoring. Although generally I prefer to use other services for logging and monitoring like Prometheus and Grafana and Loki. I will talk about those in the next session as planned as of now. But yeah, it also provides CloudWatch, which we can use for logging and monitoring. Another is VPC, which stands for Virtual Private Cloud. And we use VPCs to have isolated network environments for two systems which do not need to be in the same environment. We discussed about the actual services that we use during our application deployment, but there's something more than that for in AWS, which is identity and access management. It basically defines users, groups, and roles, which means who can access what resources. Generally, for users, groups, or roles, we attach each of those with some policies, and a policy is a JSON document that defines some fine-grained permissions. So in a policy document, what we can say is, okay, this user or this group will have access to this particular service. For example, I can create a group for interns, and I can add all the interns to that particular group, and I can attach some policy to that group which says, okay, for this group they can only view the EC2 instances and turn on and off those instances and nothing else. So this is how identity and access management works in AWS. Security groups and network. This is also a very important aspect of AWS service. Basically, security groups, or in short SGs, are virtual firewalls from which we can control inbound and outbound traffic to our AWS instances. So it also follows the principle of least privilege. Basically, the default inbound behavior is deny everything. For every access that we need to have to a particular instance, we need to explicitly mention that in the inbound rule. Ready for the next step? Check out part 2, the hands-on workshop. Click the info button to watch it. Visit careerlink.ai to explore a curated list of powerful AI tools, all designed to meet your specific needs. Dive into our live circles for a deeper, more immersive AI learning experience where you can truly deepen your knowledge and skills. Don't forget to check out our prompt library, a collection of carefully selected prompt books crafted to guide your learning journey. So, what are you waiting for? Start mastering AI today and take your career to new heights. And remember, make sure to subscribe to our channel for more content like this and stay updated.